All right, so our second way of measuring concentrations is very special and it's a little bit tricky because it involves sometimes converting units. And converting units should be trivial, it should be a piece of cake once students have gotten out of Science 10 and Math 10. But sometimes we have some issues that pop up. So, but again, since you guys are pretty good at the math, I think you're going to be able to grasp this. So, parts per million, its job is for very, very diluted solutions. Think about if you had, I don't know, a million ping pong balls. 1 part per million would be one red ping pong ball in a sea of a million total ping pong balls. So it's a very tiny, tiny amount of solute in a very large amount of solution. And there are multiple ways to express it. So the very first looks a lot like mass for mass. We have mass of solute divided by mass of solution. And since it's parts per million, we're going to multiply this by 10 to the power of 6. That's a million. So this is the very first way of measuring parts per million. So ordinarily, when we talk about parts per million, again, it has to do with very diluted solutions where there's hardly any solute in a vast amount of solution. So let's say we had (5.5 times 10 to the negative 3 grams of iron in, let's use another, or we can just use a solution. Say 500 grams of solution. So how would we calculate parts per million in this case? Again, it's very simple. So I'll take my mass of solute, so 5.5 times 10 to the minus 3 grams divided by 500 grams, and then times a million, 10 to the power of 6. So I'm going to get it into my calculator. 5.5 minus 3 divided by 500 times a million, and we get 11 parts per million. So this represents 5.5 times 10 to the minus 3 grams is a very, very small amount of grams. It's actually 5.5 milligrams. So milligrams are usually, like milligram measurements are very, very tiny. Remember, a milligram is 1,000th of a gram. So you need 1,000 milligrams in order to equal 1 gram. So for a solid in a solid, we're going to use grams over grams times 10 to the 6 times a million. But what if you've got a milligrams measurement and a kilograms measurement? We can say this: 1 part per million is 1 milligram divided by 1 kilogram. How does that work? Actually, not super complicated. A milligram is times 10 to the minus 3 grams. A kilogram is times 10 to the 3 grams. So if we convert our top number to milligrams and our bottom number to kilograms, it is in essence the exact same operation. It's the same math as multiplying by 10 to the 6. So I'm going to do one now where we have to do a unit conversion. And yeah, I know some of us don't like that, but that's okay. We'll be able to deal. So let's say 4.8 grams. Oops, I'm off home row. Of solute in $78,000 grams of solution. So here, yes, we could do grams divided by grams and then times 10 to the 6. That's true. But let's turn our solute number into milligrams. And let's turn our solution number into kilograms. So 4.8 grams. There's my conversion bracket, and I'm aiming for milligrams. There are 1,000. Oops. There are 1,000 milligrams in 1 gram. Therefore, we have 4,800 milligrams. Now we'll do the same treatment to our 78,000 grams. We're turning that into kilograms. So 78,000 grams. I get my little conversion bracket up, just like last time. This time we're trying to turn this value into kilograms. So I know that in 1 kilogram, remember that's the unit I'm trying to bring in, there are 1,000 grams. And again, we get to do unit removal or unit canceling. There's grams on top, there's grams on the bottom. So we are simply dividing by 1,000. So 78,000 divided by 1,000 is 78 kilograms. Now, just to bring it home, we need to do our little division. So milligrams number divided by kilograms number. So 4,800 milligrams divided by 78 kilograms. Whatever number comes out is going to be our ppms. So 4,800 divided by 78, 61.5. So that's going to round up to 62 parts per million. The only other version that you may encounter is for parts per million. The other way of kind of showing it is this. Concentration equals milligrams per liter. And so this is something that we would encounter, for example, if you wanted to talk about how much chlorine is in a swimming pool, or how much gold is in the ocean, or how much uranium is in the ocean, like dissolved into the water. because those substances, yes, we say that they're not soluble, but gold is very sparingly soluble, especially like we're talking about parts per million, so very tiny amounts. So all we need to do in order to get that to work is to calculate or convert our mass to milligrams and make sure that our volume is in liters. So here's an example question. "12 milligrams of solute in a 60-liter bathtub." I actually don't know how many liters a bathtub is. I've never even thought of that, to be honest. But math is going to be simple. We have 12 milligrams of solute, and we have 60 liters of solvent. And that gives us 0.2 parts per million. So 12 milligrams of solute in a 60-liter bathtub is a very, very tiny, tiny concentration. There's not a lot of solute, there's a huge amount of solution.